Hello students, welcome to Team Curiosity e-learning classes. In this lecture, we are going to learn about inductive and electromeric effect. Now, we know the organic compounds are the compounds of carbon where different atoms are held together through covalent bonds. The movement of electrons from their positions in these molecules have a great impact on its reactivity. And this electron displacement effect is this effect of displacements of electron from their position. The different ways through which electron displacements occur in a molecule are as follows. First, inductive effect. Second, electromeric effect. Third, resonance or mesomeric effect. Fourth, hyperconjugation. First, we will learn about inductive effect. We can see in a carbon-hydrogen bond, that is in hydrocarbons, the carbon have electronegativity of 2.5, whereas the hydrogen has of 2.2. The electronegative difference between the two of the atoms is very less, so these compounds are non-polar. But in alkanes, carbon-carbon and carbon-hydrogen sigma bonds are present. If we replace the hydrogen by some other atoms which differ appreciably in its electronegativity compared to carbon, then it results in the induction of polarity in the alkane molecule. For example, if we replace hydrogen by an atom like fluorine, which is more electronegative than carbon, fluorine will carry a negative charge as it will attract shared electron towards itself, and thus the carbon skeleton will carry positive charge. This carbon in turn induces a small positive charge on the adjacent carbon. Similarly, when hydrogen is replaced by an atom such as lithium, which is more electropositive than carbon, the lithium will carry a positive charge. Now, carbon, being more electronegative, attracts the share paired electron towards itself and will carry a negative charge. This induces a small negative charge on adjacent carbon atom. So, we can conclude that inductive effect is a partial shifting or displacement of sigma electrons toward a more electronegative atom in a sigma bond. The atoms or groups which are more electronegative than carbon withdraw electrons from carbon and are said to exhibit minus I effect. For example, fluorine, chlorine, bromine, iodine, hydroxide, nitride, etc. Similarly, the atoms or groups which are more electropositive compared to carbon release electron towards carbon and are said to exhibit plus I effect. For example, lithium, sodium, potassium, alkyl group, and so on. In this given figure, we can see that the fluorine atom attracts electron from the first carbon atom, thus getting a small negative charge, whereas the first carbon atom gets a small positive charge. We can also see that the subsequent carbon atoms have smaller charges. So, we can conclude that the inductive effect is properly seen only up to 2 to 3 places. As the attachment of the number of groups exhibiting either plus I or minus I effect on a carbon increases, it experiences the corresponding inductive effect to a greater extent. For example, in the given figure, we can see that as we move rightwards, the central carbon atom is connected to more number of groups exhibiting inductive effect. So, correspondingly, it shows more inductive effect. Now, here is the decreasing order of groups producing minus I effect followed by a plus I effect, taking hydrogen as the reference. Now we will understand the features of inductive effect. It is a permanent effect. This effect operates through sigma bonds only. It is observed for a maximum of up to second carbon atom of the change and ceases to operate beyond fourth carbon. An important point to note is that being a permanent effect, the inductive effect affects the physical and chemical properties of molecule such as dipole moment, rate of reaction, and their acidic basic characteristics. For example, the acidic behavior of alcohol, phenol, carboxylic acid, sulfonic acid, and basicity of amines is affected by the inductive effect of substituents. Now, we will understand about electromeric effect. What is electromeric effect? This is a temporary effect which is observed in multiple bonded systems in presence of a polar reagent. It involves the shifting of pi electrons towards one of the atom held through a multiple bond. Example: alkene, alkyne, carbonyl compounds, etc. Alkenes, as such, exist as nonpolar species. But in presence of a reagent, the pi electrons shift towards one of the carbon and the system behaves as a highly polar single bonded system as shown in the figure. A similar behavior is observed in carbonyl compound where pi electron move towards the oxygen in presence of a reagent. This happens because the oxygen has higher electronegativity compared to carbon, thus it attracts the pair of electron. As it is a temporary effect, we can see that when the polar reagent is withdrawn from the vicinity of this molecule, the transferred pi electrons come back to their original position and the molecule behaves as a pi bonded system. The electromeric effect is denoted by the symbol E. It has no fixed direction but occurs in a direction which favors the reaction. However, if a group attached to a multiple bonded carbon has plus I or minus I effect, it affects the direction of electromeric effect directly, which in turn affects the course of the reaction. In the first case, due to the inductive effect, the electron goes towards the second carbon atom. So, in return, during the reaction, the pi electron moves away from its toward the third carbon atom, giving it a negative charge, while the middle atom has a positive charge. Similarly, in the second case, as the electron goes away from the carbon by inductive effect due to the chlorine atom, during the reaction, the pi electron moves toward it. So, the second carbon atom has a negative charge, whereas the third carbon atom has a positive charge. Now, we will see about type of electromeric effects. The electromeric effect can be broken down into two types, namely the plus E effect and the minus E effect. This classification is done based on the direction in which electron pair is transferred. Now, let's discuss these two effects, that is plus E effect and minus E effect, in detail with some examples. Plus E effect. This effect occurs when the electron pair of the pi bond is moved towards the attacking reagent. The attacking reagent attaches itself to the atom which obtained an electron pair in the transfer. The plus effect is generally observed when the attacking reagent is an electrophile and the pi electrons are transferred towards the positively charged atom. In the given reaction, we can see that the attacking reagent is H plus ion, which is an electrophile as it is an electron lover. When it is near the compound, electromeric effect is seen. First, the double bond moves towards one of the carbon atom, leading it to having a small negative charge, and the other carbon atom having a positive charge. This negatively charged carbon atom then bonds with the H plus ion to give the required product. Now we will see minus E effect. This effect occurs when the electron pair of the pi bond is moved away from the attacking reagent. The attacking reagent attaches itself to the positively charged atom in the molecule, that is, the atom which loses the electron pair in the transfer. The minus E effect is generally observed when the attacking reagent is a nucleophile and the pi electrons are transferred to the atom which the attacking reagent will bond with. Here we can see that the cyanide ion or the Cn minus ion is the attacking reagent, which is a nucleophile, that is a positive charge lover. When it comes near the carbonyl group, first bond moves towards the oxygen atom giving it a negative charge, and so the carbon atom has a positive charge. Then the Cn minus ion attacks the carbon atom to give the required product.